The term friction refers to the verb group or group something. This is known as the friction force, which is the one that performs an opposition to the displacement of one surface on another or that which is opposed to a movement. The friction as force is caused by the interaction or imperfections between objects that maintain contact and can be less so much as things that we cannot come to see and as things that if we can see. And with this, a friction angle is generated. Also, the friction force is proportional to the friction coefficient, but the amount of force required to move an object from rest is usually greater than the force required to keep it, while maintaining it at a constant speed. For this reason, two friction coefficients are sometimes cited for a given pair of surfaces, a static friction coefficient and one kinematic. The extension of the thread of both can be a static model of friction and depends on several assumptions about the friction. We have the friction formula, which is F is equal mu times N, which F is friction force, mu is coefficient of friction, and N is normal force. Is in our day-to-day without giving us any, since they can be very minuscule things as already mentioned above. These are some examples. The wheels of a car that move on the pavement, the roving of a plane in the air, when it flies, rubbing stones or wood to generate hidden fire, the sole of the shoes, when rubbing hands or other part of the body. As we can see, the friction is found in very small things and that we don't realize, and it is widespread in many areas.
Static friction is a force that resists the initiation of sliding motion between two surfaces that are in contact and at rest. Kinetic friction is the force that opposes the movement of two surfaces that are in contact and are sliding over each other. Free body diagram, which is a graphic illustration used to visualize or apply the forces and the reactions caused in a body. Coefficient of friction is the ratio between the force necessary to move one surface horizontally over another and the pressure between the two surfaces.
To obtain the results, we use some formulas. The first one we used was the average formula, adding all the values and dividing it by the amount of values. In our case, it will be the sum of the angles of the 10 repetitions between 10, which is the number of angles, and we use it to obtain the average critical angle of the 10 test. Formula came out of an analysis which starts with the static friction from that is equal to the static force divided by the normal force. Then we replace the values gives the normal and friction force. It will be equals to the product of the mass times the sine of the angle divided by the product of the mass times the cosine of the angle, and then from which we can eliminate the masses and changing the division of the sine between the cosine just to a tangent of the same angle, remaining the formula of mi equals tangent of the average angle, and it is used to obtain the coefficient of static friction.
Step 1. Place the plane at ground level and have the stream A hinged. Make sure that the stream A remains fixed. The only stream that can rotate it is stream B. Step 2. Attach the thick surface, in this case foamy, to the base of the container. You can stick with glue. Step 3. Place the first object inside the container and put the container at the center of stream B. Step 4. Very slowly raise the level of the stream B so that the plane passes through the different angles. Step 5. At the same point, you will see the container start to slide downwards. Stop raising the plane at the point and record the angle with the protractor for which this happens. Repeat this process 10 times more and record the critical angle for each repetition. Always make sure to raise the plane very slowly and continuously. Step 7. Calculate the average of this critical angle with these 10 repetitions. Step 8. Finally, calculate the coefficient of the static friction. Step 9. Try the same experiment for the other two objects to confirm that the static friction is the same as before.
The material that we choose is bony. The first object, mass 1, is the sharpener, which has a mass of 25 grams. Also, we obtain the average of the critical angle according to the 10 tries that we make, which is 37.5. And the coefficient of the friction is equal to 0.76. The second object is an stapler, which has a mass of 100 grams. The average of the critical angle is 38.5 according to the 10 tries we made, and its coefficient of friction is equal to 0.79. Finally, the third object was a mirror, which has a mass of 150 grams. The average of the critical angle is 38.4, and the coefficient of the friction that we obtained is 0.79.
We prove that in many cases, the friction coefficient is the same for the same material, but it can vary, because for a rise, the beginning of the motion may be different, since we have different parameters, and we can make mistakes. Also, in the practice, the angles that not varies a lot, and we saw similar results without big difference in those ones that change.